discussion, which is about technologies and operations and the superstructure in general. We would be discussing how to make it better, not cheaper, but more efficient and more reliable. My name is Alexey Kharnas. I'm editor-in-chief of GUDOK newspaper. I will be moderating our today's session. First of all, I would like to thank all of you for finding time to come to this Nishta testing range in Sherbenka. It is quite early hour. Please remember that we're going to use two languages, so if you're not sure about your English, you can type the device that would be providing you with a simultaneous interpretation into English, into Russian, sorry. So, colleagues, indeed, to set the mood for this panel, I would suggest to all of us, both in the room today and on the internet, to have some poll, to take some poll and to vote. We prepared a number of questions for you. You will have a QR code. If you can direct your cameras on the QR code, you will be receiving a link to the questions. Please take some time to answer those questions. And of course, our audience online can do the same and vote in the same manner. The question is quite simple. What would be the most efficient way of reducing the cost of operation of superstructure? New technologies and new materials. 1, 2, optimizing the number of personnel, maintenance personnel, and of course optimizing means not only reducing the numbers but also increasing the numbers, changing the relationships with the contractors, and also government regulation of the prices on materials and equipment. Quite a debatable question, but anyways. And colleagues, I understand that we are going into somebody else's story, and this is the wrong QR code. This is actually a QR code for the questions that we had yesterday. So we will be replacing the QR code right now. Well, I do not know. Maybe this is some complot from the traction department. They actually assumed all our QR codes and they are ruling the world. So colleagues, probably we'll just postpone our voting and we will have it after the first presentation while our colleagues would change the QR code and give us the right one. So let us not really waste any time, and we'll take the poll later. Indeed, we have many things to discuss today, things and topics that are important and interesting, but obviously we need to start with the main thing and talk about which technologies of maintaining superstructures are seen as priority ones for the company, what the Russian railways need and what should be the focus of developers, maintenance personnel, etc. So those kind of like disruptive points that should be the focus of our efforts. I would give the floor now to Alexander Boretsky, Director of the Design Bureau for Infrastructure, a branch of Russian Railways. So thank you. Indeed, dear colleagues, I'm happy to welcome you here at this anniversary event of Motion.Expo. This is our 10th year of such events. Well, actually, it is 50 years now, because we opened our testing range in Sherbenka in 1971, and we had the first expo. And since then, every year, we are presenting everything new available in the railway transportation. Everything is being tested here, and it is here that we more or less give life to any new ideas and new equipment. I would like to thank the organizers of this event, of this expo. It is our second day of such an expo in very difficult circumstances of the pandemic, but I don't think that anything can replace this face-to-face communication which we are enjoying for the second day today. Indeed, yesterday I met many of my colleagues whom I have not really seen for quite some time, and we were able to exchange opinions about how things are being developed, designed, and implemented. And also, some market players were presenting yesterday some of the new machinery and equipment, and you can talk to the vendors, you can talk to the people and ask questions. Perhaps some of those are quite interesting, and this is important and necessary for us to move on. Yesterday, at the opening ceremony, which was taking place in the central building here on site, it was announced that in the year 2021 is the year for Europe, the year of railways for Europe, and for the Russian railways, this is the year of the environment. But generally speaking, for Russia, this is the year of science and new technology. So these three key points were highlighted in the presentations yesterday. It was mentioned that almost in all areas, Russian railways is a leader, and in Eurasia and generally. And yesterday we also received questions to identify what are the most relevant issues that can be discussed, and it was also the environment, the climate, it was competition in terms of transportation services, and Oleg Belozorov, the CEO of Russian Railways, said that one of the key points that are of interest to Russian Railways is the reallocation of the cargo flows, which we see. Those flows are changing. And it is not really controlled by the Russian Railways. There are some shippers who would like to take their cargoes here or there, and we do see that the maximum load is in the eastern area. The annual growth is visible there, and it is quite important to increase the throughput capacity and upkeep the infrastructure in the eastern area of Russia. Now, if you take some of the sections of the road, Zabaikalskaya, or Far Eastern, etc., the daily throughput of trains is up to 100 pairs of trains, or like 8 trains an hour. And this is very heavy traffic, but we also need to maintain and repair our trucks there to provide some current repairs as well as overhauls. This is the general issue for Russian railways, but I think that it is most acute in the eastern part of the country. So the task today is really to ask ourselves what to do. How can we combine both the traffic and the maintenance operations on the infrastructure? There have been some solutions offered, and they are being implemented right now. And of course, one of the points is really to have short intervals between the trains, and there what is important is automation and telemetrics and telemechanics, and already this year in mounting passes we started to install new signals and equipment, and we are implementing this new system. This is like a virtual coupling. This is also increasing the speeds of the trains. We are removing any restrictions that may occur when there are some failures, technical failures of devices, etc. And one of the key tasks, of course, today is to more or less announce less windows or shorter windows for maintenance and how that can be done. Of course, primarily, and it is mostly about trucks. Of course, you need to increase the life of the superstructure and of trucks so that we can have extended maintenance periods. If today is like 700 million kilometers and you need to repair the trucks, that is the norm today, but the task is now set by the Minister of Industry and Trade, Mr. Monterov, that we really need to make sure that 2.5 billion kilometers would be, well, that is over the period until 2030. We need to make sure that the life cycle of the superstructure should be 2.5 billion brutto tons per kilometer, not the 700,000 tons per kilometer as today. And we have been looking into this challenge. There are some advances already, and we do get some support from the academics and research and the designers of the superstructure. We are now installing superstructures with the rated throughput capacity of 1.4 billion tons per kilometer. So we are working with the metalworks and with the research to produce better rails and those were resistant and low temperature resistant. And already the rails today that we are producing together and developed together with Yevraz, and they are actually demonstrated here in Sherbinka, and they are showing very good performance. Now, if you take like mountain crosses, which are the most difficult ones to operate the trains, there we are still facing some challenges with using the new type of rails. However, on average, we are having already 1.4 billion tons per kilometer, and we also see some support from the producers of bars, and the vendors of fixtures are also offering some warranty for 1.4 billion. Many of them actually are offering already some fixtures that are good for 2.5 bill. And of course, this means that we can really try to follow the track of making sure that by the year 2030 we would be rated at 2.5 billion tons per kilometer in terms of the life cycle of the superstructure. Also, we had to also provide maintenance on some more challenging sections once every 7 years, but today with the longer lifespan of 1.4 billion, we can do the maintenance and repairs once every 14 years. And of course, we need to be thinking about some current operations of the tracks and to provide some preventive maintenance, etc. And this is important also to make sure that the track is in line with the design in terms of its geometry, and we need also to have some good measuring equipment to test and measure the tracks. And of course, the work of the tracks and superstructure is very difficult, and the tolerances there are only like millimeters. And for that, of course, you need to have very high capacity equipment to measure the accuracy of the track. So we are getting some equipment, but this is not the limit, and we need to be moving on. Also, to extend the life cycle of the rails. We need to grind the rails, and we are working now with the vendors. We need also to make sure that we have speeds. We have longer lifespans of the superstructure, etc. And of course, track maintenance. We do have the tasks set for us in terms of maintenance, and if we sometimes would repair a kilometer of the track during the window of maintenance. Today we can repair 3 kilometers of the track. This is still like at the testing phase, but it is quite realistic to do so. And the minister indeed said that this is the task of today. And the task and the challenge that he's setting to us, Mr. Moderator, is that we need to be trying to repair and maintain at least 10 kilometers a day of the track. Today we're at 3 kilometers, but even to reach the 3 kilometers, we need really to more or less put up a whole trains of track machines to clean the gravel, to clean the sleepers, etc. It is quite costly, and currently we need to have some machines that are very high capacity and using not like 6 or 7 machines as today in like more or less like next to each other, but maybe use 1 or 2 or 3 machines, like big ones. We're not talking about some individual pieces of equipment, like we need this machine or that machine. We are saying that it should be really kind of like a composite fleet of machines that would be covering the full of the track, and that can really be moving at high speeds to repair and maintain the tracks. So these are the machines, like a suite of machines that we can use. And of course, some ongoing and continuous maintenance. This is probably the costliest part of the maintenance job for the tracks. But of course, you have to do that, and but we need to be more to be more rational and optimize our labor inputs. We need to really try to get rid of many manual operations, and where possible, and of course use some like robots where possible. Something that we are using already today. So we have some automated machines to replace the sleepers, and this is done by robots, not by humans anymore. However, we need, of course, to have smaller machines as well to be employed. Like last year and this year, we were testing some smaller machines in Oktyabrskaya Railway and in Moscow Railway. Some, say, new sources of power, like smaller batteries that have more capacity and can be used for small-scale mechanization of some operations. Something that we are doing right now, but we are using, say, some gas engines and motors, and this is something of the past, I would say, so we need to be moving on to some better technologies. Of course, diagnostics, this is very important as well. Alexander, I would need to remind you about the timing, please. Well, diagnostics and diagnostic experts and analysts would be our ears and eyes, and if before we were using diagnostics to prevent any failures, but now diagnostic experts, they are looking through the track to optimize our work. So there are many really tasks that we face in the infrastructural department of Russian Railways. I only highlighted some of the key ones. They are difficult, but they are quite realistic, and together, the vendors of machines, science and research, and operations, we all be able to really resolve those tasks. Thank you very much. And indeed, we can see that the range of challenges and tasks is very broad, and we need to have also some broad solutions to be offered. My colleagues prompted to me that finally we have the right QR code, which would provide you with the right link to our poll. So please take another snapshot of the QR code. And the question really is one: what is the most efficient way to reduce the cost of operation of the superstructure, with 4 options: use of new technologies and materials, optimizing the manpower to operate and maintain the superstructure, change the relationships with the contractors, and the government regulation of the core materials and equipment. I would say that the options there are quite debatable, I would say. So we will see how it goes. I understand that we are offering a minute for people to vote on any particular option of an answer. And by the way, the voting, if you like, is anonymous, so nobody would know how you answered. So please choose the right answer. Let's train ourselves to make the right choice on September 17th during the parliamentary elections in Russia. So this is kind of like a good test for you. So colleagues, are we ready with the poll results? Well, we will be showing that on screen, but the only request I have, maybe I can actually announce the results. Use of new technologies, 84%, optimizing the manpower, 0%, change of contractor relationships is 8%, and public regulation of prices is also 8%. So, as you can see, it is quite illustrative to see the outcome of the poll. Indeed, we are focusing on new materials and technologies, but maybe we will have a change of the attitude after our discussion here today. Now, I would like to give the floor to Mikhail Lvov, the first deputy director of the Department for Track Maintenance. Now we are actually going through the summer campaign, if you like, of track repairs. So we are using some new materials and technologies. So what is the benefit of that? Good morning, dear colleagues and dear audience. I'm happy that we're all here to discuss many important things, and of course, I am happy about that. But I also want to wish you good health, because we are still in the pandemic. Now, regarding the track maintenance, I should say that we have several strategic tasks and challenges that we set for ourselves, and already today we discussed some eastern area of which is experiencing some heavy traffic. And when I worked in Zabaikalsky section of the track, we were surprised to see 65 pairs of trains. But now we see that the number is growing to 100 pairs. And of course, this puts some burden on us, and when we first started to maintain the Zabaikalsky section of the road, we were taking like 10 days to repair a section. Now we are more or less within 3 days, and we are being asked to reduce that time to 2 days, but at the same time provide the good quality and ensure the high speeds of the trains. We are testing that right now, and more or less we are trying to repair the 3 kilometers per day. This is already the norm for Zabaikalsky railroad section. We talked about the eastern area, but we have several focuses, like the connection between Oktyabrskaya and Severnaya railroads. This is also important, and we are using there some disruptive technologies to maximize our output. Now, a few words about a few slides of my presentation. I should say that during when I've spent some time in the track maintenance department, and we already provided some good performance there. So we would be looking into the use of some of the experimental technologies that were tested in the various sections. Those are being put together, integrated, and are being deployed universally. So our performance is in the more or less numbers. So we reduced the number of personnel as well, and we were looking into our man table, and we realized that we need to think about the auxiliary personnel more. And we are training our personnel in some additional skills to increase their performance and their knowledge and their employment. And we mentioned that today we have certain tasks set forth by the government, and the President of the Russian Federation actually this year kind of like draw the attention of Oleg Belozerov to the fact that there are some delays in the repairs, and we need to make sure that we would avoid those. This is what we have today, what we declared in terms of our long-term development, and I should say that we will still have some meeting with the Vice Premier, Mr. Belousov, where we would be discussing the progress in track repairs. But I should say that in 2022, we have the task of repairing almost like 1,000 kilometers of the tracks. There's another second task whereby we need also to increase the throughput capacity of the tracks, including to the Far Eastern ports, which are getting more and more loads. So it is not only the Central Directorate for Track Repairs that is getting those tasks, but we do see that new tracks are being built and the areas are being developed where the new tracks are needed. Regarding the resources that we have, I should say that the use of some common equipment and common strategy of using such equipment made it possible for us to increase the operation rate of our equipment. We increased our efficiency by 54%. So we are also using better our cranes, and I should say that this is thanks to our vendors as well, and who provided us with new equipment in terms of the delivery of the equipment and the specs of such equipment. And we also see that we increased the performance of other equipment by almost 95%. And Dmitry Leonidovich is presenting more on that later, but we are really using those machines in a better way. So talking about some efficiency, I should say that this is the VPO machine that more or less can provide us with better performance. Now, even the use of this one machine would provide you like a good saving of 28 million rubles per year. That is from the use of only one such surfacing, tamping, and finishing machine. Now, regarding our track machines, I should say that we are improving, and the specifications of the cranes, and we used to have 2 operators on the crane. Now they are only employing 1, and of course the labor conditions being improved. For example, we are making sure that they have the cabins in place, and the performance is up to 900 meters an hour. Now the cost recovery is presented there, and the motor platforms in the middle of this slide. And another hoisting platforms, they are providing better effects, and we are saving up to 12 million rubles a year. Looking forward, of course, we already saw some of the new machinery being offered by the vendors and designers. This is our future. Maybe this is not the end of it, but this MPV machine would replace at least 5 types of other equipment, and another machine which is used to replace some strings, and we are still using some old ones, but we are now using new technologies, PRSM and others, and our vendors are promising to us that they will be able to provide new equipment to change the whole picture as follows. Now 5 kilometers takes 3 days, and we are still using 3 such machines in the northern section of the railroad. One is in the testing range, in the testing mode, and we do see that such string replacement machines are quite good, and they can be run smoothly. The MPV machines and KSP machines, those new types of machines will really accelerate our operations by 18 hours, and we can at least free up to 49 personnel to do other jobs instead of being employed in that old type of the machines. And we can also release 4 locomotives for other operations. Also, what we can expect in terms of what we are doing, we do see some deficit in the throughput capacity and the rail strings, and they are brought to RSCP, then they are welded into the strings of up to 800 meters, and I should say that the future is for some mobile train or welding train to weld the strings that would make sure that we can avoid some idle running and transportation of those strings. So this is kind of like the message, and for us, that our next iteration would be to efficiently use the resources available. And slide, on my last slide probably is what I said. This is something that we are hoping to achieve as the result of our improvements together with the vendors. Thank you very much. Indeed, thank you. And we heard the position of the company, of the customer. But we also need to be asking those who are producing those materials and equipment. And I would like to give the floor now to Dmitry Ryanok, the first deputy CEO for operations of PTK Group. I understand that you also have a presentation. Thank you very much for providing me with this opportunity to present during this important event. By the way, in the beginning, I would like to say that the presentation is called to increase the throughput capacity by using new track repair technologies. However, my colleagues already mentioned that to increase the capacity of the railways is something where we not only should be thinking about track maintenance and repairs, but also we should be thinking about other factors that would affect that. And our project is focusing on the infrastructural aspect of this global task of increasing the throughput capacity that I would say the country is really facing. On slide here, we have the project passport, if you like a profile, and some economics of that project. The idea of the project is how to influence and how to ensure the better efficiency of Russian railroads, and to have some synergy of three components in introducing new technologies and machines. And we saw during the poll that this is kind of like the preferred option for my colleagues, that new technologies indeed would be the driver that would increase the efficiency of our operations. And of course, next we need to increase the throughput, of course, and we're talking about some maintenance windows and the speeds of movement after the repairs and maintenance. And of course, we need to reduce the operational costs on the upkeep of the infrastructure. What Alexander Adamovich said, indeed, the idea is not to really make the track heavier, but the idea is that in the end of the day, we need to really reduce the operational costs, because operational costs are incomparable with the maintenance costs. The feasibility parameters here, quite briefly here, this is not our numbers, I would say. These are the estimates that we did together with the experts from Russian railways. And last year, the research councils of the St. Petersburg and Rostov research institutions also looked into those estimates and confirmed that in principle this is the right approach, and confirmed that those estimates were correct. I should say that the project is not really our PTK Group project, but this is the fruit of our cooperation with the experts of Russian railways, and we were supported also by the Tula region administration, and as part of the federal project of science in 15 provinces of Russia. There are some leading research centers being established in many areas, including in Tula. And our project is really part and parcel of that package of research ideas offered to those research centers. We're talking about some step-by-step implementation. And last year, Russian railways also adopted a plan for the introduction of new technologies in 3 steps and 3 phases. And the first phase or step in 2021, by the way, this is referring to the question of our moderator about the new technologies to be employed. And this is again with the support of the Central Directorate for Track Maintenance and Repairs, and we actually used some high-speed machines to clean the ballast, and We do have the most advanced machines now, and they demonstrated the performance that was put into the design. And the effects of those machines was really quite large. And Vanity experts also suggested or probably thought that the operation of those machines would make it possible to change the existing rules to increase the speeds from the current 60 kilometers per hour to 80 and more kilometers. And of course, we may include this into some additional research, and our colleagues from the Transportation Research Institute are looking into such a possible increase of the speeds. And of course, this would fit nicely with the higher capacity, throughput capacity of the railroads. I mean, increasing the speeds by 20 kilometers would really support the idea of carrying more cargoes. And the second phase, which was suggested for this year, but we're asking to postpone it until next year. And this is about testing some testing of the so-called third level maintenance operations. And here we are presenting some of the machines, truck machines that we use and our partners use. And the performance should be almost like 10 kilometers of maintenance per day. And again, already next year, we may provide a solution to the task which was put forward by the strategy of really achieving the 10 kilometers of maintenance per day. Now, the two phases, again, but this is only the beginning of the way, and the project suggests some further developments like carrying heavy cargoes and high speeds, etc. But I think that the outcome of this project would really help develop the infrastructure and increase the throughput capacity of the railroads. And the infrastructural complex would confirm that it is not only about costs, it is not only a cost center, but if you take the right approach, it would be also of very good economic performance, which is important for the Russian railways. Thank you very much. And indeed, colleagues, today, as our guests, we have another representative of a large vendor of truck machines, Kirill Epstein, CEO of RPM Group. And I would like to give the floor now to him and ask the question. Of the technologies that you are using today, which one you would call disruptive and which one you would think to hold the future? Thank you very much. Again, I would like to also try to show my presentation to you. Indeed, my name is Kirill Epstein, CEO of RPM Group, and my group includes two enterprises, the Kaluga Track Machines Plant and RPM. And of course, we are working on the production and sales of track machines. We're going to talk about our product line and our promotion. It's not really about sales, but it's like a promotion and marketing of services. And I would try to take those questions that were asked of me by the moderator and would discuss some of the challenges that we may be facing. It is an open secret, and we have heard this before, that the maintenance of tracks should increase the speeds and improve better quality of services and safety and reliability. How to meet those challenges? People are talking about digitalization, and indeed, this is making our services, our infrastructure digital, new composite materials. These are the continuous welded tracks, but also a thing that we mentioned today largely, but this is also providing such maintenance operations to third-party contractors, something that is being done in Finland. If you take a look at the market and the trends, of course, the machines are going to have a higher performance. They would cost more, but we will have to use smaller numbers of those machines. Indeed, if today we are using, say, 1,200 machines for track maintenance, then the tendency by the year 2025 would be to only employ slightly more than 1,000 machines. And my company is operating in several areas like snow removal machines, repairs of rail cars, etc., and delivery means. What STM does, my group of companies, is really to provide comprehensive services and entering the markets of railroad services. We are convinced that in today's world you have two types of companies, like fast companies and dead companies. Not to be a dead company, you need to really introduce and use a lot of machinery, because the market is really highly competitive. My previous colleagues mentioned that. Now, a few years back, we would kind of like feel safe to be the alpha vendor here, but today it is not the same story. We have competitors now, which is good, because the result is like stronger machines. And we are producing new types of machines, like we did so in 2020, 3 new types of machines, and in the next 5 years we will be offering 13 more machines. Quite a challenge, but why would we need that? So for 2020, these machines were demonstrated today. For example, the crane 2525 with the double cabin. It is available on the Expo site. So we modernized the platform. We actually reduced the height of that machine, and this is a safety feature. We can avoid damaging the cables on the tracks, and we actually reduced the height by 300 millimeters. We also provided lighting on the machines, which is important. We're optimizing the number of personnel. We had 2 operators on that crane. Now we have only 1. And we can also really operate remotely some of the parts of that crane. And these are the numbers, how it affected the performance and the economics. With the crane, this is only step 1, and I will be talking more about that and about the train. So the maximum speed of the crane is increased by 30%. We are also increasing the lifting capacity of the platform, and we are reducing the number of personnel. We have now 2 cabins, like the left one and the right one. So depending on where you want, you can operate the crane. And we can also operate the crane remotely. This is quite real. This is already a thing of today. You can see that on the Expo site and see that with your own eyes. Now, next challenges, say the train and we there would need to provide a universal comprehensive solution for the tracks, and we can decrease the number of personnel, and the performance is much better. For example, if you take the recent measurements, it's 294 meters of track. We were talking about 500. I also heard some plans to increase that to 900 meters, but also some technical things like the machines to weld and kind of like put together the seams. And of course, colleagues are also demonstrated the machine, which is called KSP, and we are also developing such machines. We call it KSARP, that is a machine to replace the strings, and in 2024 we are going to offer that machine to our customers with less personnel and with higher performance, and this would be kind of like a very new idea of a machine. Also, the cleaning of the ballast, and of course, we understand that our today's machines are not really very modern solutions. My competitors and colleagues have kind of like better designs, but we know how to rework our machinery to be competitive. And we are launching new machines, which will increase the performance for such things as laying the ballast. We are launching a dosing hopper. You can also see that. We think that and expect that we are going to have the positive decision of the Russian Technical Examination Board on that. And again, you can see that in our expo here on site. This is already the reality. Colleagues today actually talked about the streamlining of the tracks. Historically, we had those machines, but we are following the way of upgrades, and it is quite a thing for us. The delivery of personnel, we also have new types of rail cars that can be traveling at speeds of up to 120 kilometers an hour. And in terms of efficiency, it also has a hybrid boiler which can operate on 3 types of fuel. In September, we will be also testing that rail car. So we are trying to upgrade the cars so that it can be operated at temperatures of up to minus 40 degrees Celsius. And we expect to have the positive review of that rail car. In terms of rail grinding, indeed, we also had some positive tests this year. The idea is to increase the speeds up to 15 kilometers an hour. Well, we currently reached 12, but we are hoping to reach the 15 kilometers mark. We will be sharing that secret a bit later, but we are working on that machine, and in 2023, 2024, we would be offering the machine to the customers. Rough grinding to remove like 3 millimeters of the rail. We are also looking into such a solution and such equipment. Hope that we will have that available in 2023. Snow removal, 2 machines there, the previous generation machine, PSS-1 train. We are launching a new machine there, which is PSS-2P, which is modern, operating at higher speeds, but with fewer personnel. And the first task that was put forth for us is that we also need to have an option for that train to operate in summer to clean the tracks. Well, we thought to do that later, but actually we were told really we need such an option, a functionality of that train right now, and we will be doing that next year. For the snow remover, we saw here on the expo that such a machine is available from our competitors. We are going to compete there. We will try to compete. We do have a strong capacity of producing such machines. This is kind of like a very promising type of equipment. So I discussed some of the new equipment, but all such equipment is designed to work and use new modern materials. Let me remind you about our time. So I'm finishing. So these are the materials that we are focusing on. We are really using modern technologies and modern machinery, which can employ any modern materials. So to conclude, I should say that we are working today to produce equipment, but looking forward, there are 2 main things, like full service and life cycle contracts, where we need to work, and also transiting from the sales of machinery to the sale of services. And for that, we have a new directorate in our company. Mr. Vitarevsky can be sharing more with you about our services function. We are going to go into that market because it really holds the future for us. For STM, we really know that if you are not thinking about future, your present is going to finish and be over very fast. Do I understand correctly that we can go to the expo to see the machinery? Yes, of course. All that machinery, all those truck machines are available. We are kind of like showing the crane with the 2 cabins, and actually you can go into those cabins. We have TSO2 there. We have the hopper also demonstrated at the expo. We have the IM machine that we produced. I mean, not this year, but last year. But we are still showing it off here today, and we can also show to you the high-speed platform, which can travel at speeds of up to 140 kilometers an hour. So you can go out and see that standing on the trucks here at the expo. Now, going from equipment to materials, because of course the superstructure includes not only machines but also materials. We all know about classical materials and elements of the superstructure, but recently we heard about some unusual things. So I would like to give the floor now to Andrei Ushakov, CEO of Apatec. And we would like to discuss new materials, where those can be used and how they can be used and implemented in a broader sense. Well, can we please have the presentation? Dear colleagues, indeed, I'm Vyacheslav Yermakov. I'm not Andrei Ushakov, as was mentioned. Am I going to have the presentation? Colleagues, indeed, in continuation of what we have discussed so far and what Alexander Adamovich started off with, this is the task that is put forward to the Russian railways and to our research and science and vendors, and that is increasing the load to 2.5 billion tons kilometer, and this is quite an ambitious task of going from the current performance. Second, in the world today, it is quite well known and proved that a strong driver of development, not only of the railways, but also of the industry that supports that, would be the high-speed tracks.
Today, the companies which are capable of building high-speed trains are located in 4 to 5 countries. And this is quite unique, just like in case of aircrafts. Therefore, high-speed traffic, this is a separate part of the railway system, which in a sense provides for the real breakthrough in technologies in general. And therefore, this objective, on the one hand, of providing necessary resources, 2.5 billion, and the high-speed traffic, we decided to bring together in our vision of how to address that problem. So how a promising structure should look like, what requirements it has to meet. So the resources, 2.5 billion tons, and same resources and service life of all the elements when the crushed stone actually has a service life of about 100 years. We're speaking about the service life, and in the case of the high-speed traffic, actually with the overall load of about 25 million, so the crushed stones should serve at least 100 years. This should be the minimum scope of repairs and maintenance, etc. Let us get back to the objective put in front of us. So there is an objective to improve the service life 3.5 times. The question arises whether this is realistic using the state-of-the-art materials. So the crushed stone, steel, or concrete, unfortunately, they would depreciate in the process of operation. And over 100 or 200 years of operation, all the resources of optimization now are exhausted. There will be no breakthroughs. Therefore, we find ourselves in such a situation prior to addressing that objective. That's a general picture at the moment. We have actually the standard of about 600 million. The once actually we proceed with the unballasted mode, the concrete would serve us about 60 years. Unfortunately, it would not serve longer. And at the moment, actually, we would focus on the figure of about 700 million. So this is what we suggest. The rails would be made of steel. And unfortunately, that would be the weakest link in terms of the service life. And other elements of the track would be made of composite materials. And the service life would be about 100 years. The composite materials are not vulnerable to the ambient environment. Unlike steel or concrete, composite materials would not crush or would not degrade. Over 40 years of using composite materials, unfortunately, we have not lived to see whether it would serve for about 100 years. But all these physical and mechanical characteristics do not deteriorate in these materials. Therefore, the use of these materials gives us an opportunity to create a product of a totally new quality, which can meet these ambitious goals which are put forward by the government in front of the railway industry. What we have at hand? What developments are there? For instance, these are the fixtures. That's a steel screw. And it is for 40 years that we are using the composite materials in the springs. So the composite materials made springs, that's the best practice. Therefore, there is no problem of making other materials out of composite materials. As for other fixtures, such as the screws or bolts and nuts, that's very easy. So once there is no steel, it means that it is corrosion-free, and therefore the service life is improved very much. As for the bed is concerned, for instance, these are the unbalanced slabs, and that's the railway bridge, which, thanks to the breakthrough decision taken by the Russian Railways Administration, was done. We were instructed to do that. This is what we done, and we erected that in January. And 262 million tons of cargo has been transported over it, and it means that we actually meet totally the requirements. We confirm the design parameters by tests, and these tests have been done by the Russian Railways R&D Institute for Bridges, along with the All-Russian Railway R&D Institute of Nizhd. So it means that the Europeans are using the earth bed. China uses the crossovers made of iron and concrete materials, and again, concrete would serve for no more than 60 years. And 30 years after this is being launched. A big labor market is being created in order to maintain iron concrete. China actually can afford that. But we believe that all the materials have to be made of composite, and the resistance and the strength of such materials have been confirmed. We have about 20 years experience of using pedestrian bridges made of composite materials. We have an experience of using such bridges with a span of more than 300 meters rather than 20 meters, and such designs have been approved by the Bridges R&D Institute. We have necessary documents which confirm that that's very much realistic, that's very much viable. As for the regulations are concerned, it does exist. There is a stereotype that there are no regulations so far, but there is a permit issued by the Ministry of Construction. We have such permits and certificates, therefore. We have no problem obtaining necessary approvals from the experts. And to conclude my presentation, unfortunately, I do not have any more slides, so let me sum it up the following way. In our point of view, 2.5 billion tons of capacity using the molding materials is totally unrealistic. Looking at the 40 years experience of using composite materials, and Russian Railways is among the leaders in terms of using the crucial infrastructure. This experience showed that such materials did not deteriorate over the term of its service life, and the noise effect decreases very much. Let me remind you of the time limit. Actually, we reduced the noise to 8 decibel. Therefore, using polymer materials allows us to make totally new products, and therefore we can address this ambitious issue of reaching 2.5 billion tons of capacity. This unique bridge, where actually is it installed, where it is erected? Actually, it is located 1.5 kilometers away from here, the third circle, and if you have not seen that yet, actually, you may walk 15 minutes and look at that, look at the slabs and the bridge itself. Thank you so much. So it means that all the novelties actually are located here at Sherbinka, so it looks like Railway Skolkovo. And saying that, I would like to pass the floor to our next speaker. And let's speak about how to bring down the cost of the superstructure in general. So I pass the floor to Armand Babikan, Deputy Head of Promash-KZ. Over to you. Good afternoon, dear colleagues. Promash-KZ, this is the only factory in Russia which makes the switches, and it is part and parcel of Krasisymsky DZ located at Ekibastus. One of our main partners in that sense, and actually which thinks alike, is Timarjali from Kazakhstan. For 10 years, we're doing everything in order to bring down the cost of the service life of the switches. Our experience showed that one of the problems is instability of the rail gauge in the middle and end of the switch. Therefore, 6 years ago, once iron concrete bars were designed in order to avoid issues in production, we decided to make long line bars. And these bars are designed to carry the rolling stock with the load of 27 tons per axis. And it has a warranty of about 300 million tons of weight in terms of tonnage, which meets the requirements of the new state standard 32942. These bars helped us to make standard production of the switches of grades 1.9 and 1.2. 5 years ago, after the successful tests, we launched the serial production of the switches, which would be fixed using the bolts, and it got an acclaim from among the customers. The Azerbaijani Railways used that when building a railway corridor from Baku to Tbilisi to Kars. In 2019, we developed a special switch with resistant fixtures, and also we made a special roll system, KZ93. We fine-tuned the bars in order to automatically fix the switches without having to switch to the manual mode. The switches were installed using district layer machines, and handling were done by the pneumatic and stabilizer of the gauge. After carrying 10 million tons of cargo, in order to avoid the human factor in the contractors, in order to avoid the crushing out of the core, we actually made this core within the factory, within the plant. The test showed that the switches are quite reliable and retain the sustainability and allows to increase the speed of the trains without necessary upgrading the entries. The switches would work flawlessly, therefore the drives may serve longer, and the failure rate goes down. So these methods helped us to improve the service life of the switches, and actually the design service life is 120 million tons, and more than 180 million tons of cargo has been passed through these switches. There is room for improvement. We have not exhausted these opportunities, but today we see that the use of the innovative technologies improve the service life of the switch and brings down the maintenance costs. Thank you so much for your attention. Thank you. Well, I think that that's a very interesting experience, and I do think that after our roundtable we can discuss that offline the conference and speak about that. Dear colleagues, and so that I would like to proceed with the presentation of our next speaker. Unfortunately, he failed to come. We know that the borders are closed, but he is online with us, which is habitual for the pandemic times. And saying that, I would like to pass the floor to Sales and Marketing Director of Almaternis, subsidiary of Saint-Sophie, Anthony Victor Mel. Let me remind you that we all have devices for simultaneous translation. The first channel is for the Russian language. Anthony Victor will tell us about the experience of the company, about some promising technologies. Over to you.
Okay, good morning, everybody. I hope you can hear me in English. I was, of course, not able to come to Russia today because of the COVID situation and all these reasons. But it's good to see that you were able to maintain these events, 15-20 events, and to get the railway family together in Russia. I was asked to go on this presentation without the presentation, so you can look at the presentation later. I just wanted to give you a few insights of how things are done differently in SNCF Réseau, thanks to Altametris. Altametris is a tiny company. We're very small. We are 50 people. And we are a direct subsidiary of SNCF Réseau, which is operation and maintenance of the railway infrastructure, versus SNCF Mobility, which is about trains and ticketing. So we are a subsidiary of the entity in charge of operating and maintaining the network. So SNCF Réseau is facing a challenge today. It has an aging staff because a lot of the highly trained experts are now going towards retirement, and a lot of the auditors and experts in railway infrastructure are now leaving slowly the company. On the other hand, you have rising costs of maintenance and so on. So the challenge that we are faced and that Altametris is trying to solve is how to generate performance with less tools, less people, and in an environment where resources are limited. So one of the answers we thought of is drones, as you can see on the picture. If we start to fly over the network and start to gather more and more data, we can collect more data, produce more data. So yes, that can be one answer, but when you produce gigabytes of data, then you face another issue, is that you don't have enough people to analyze all this data. So drones are not the answer alone, and data is not the answer alone. So we were thinking, okay, if we are using algorithms, if we are using artificial intelligence to go through all these pictures and to go through all this data we are generating, are we helping our shareholder by providing them actionable information? So again, the answer was no, because if you use an algorithm itself is not smart. It can help you go from millions of pictures to thousands of pictures. But then you still have to know what you're looking for, what kind of defects you're looking for, and what I want to say is whether these defects are critical or not critical. So you need some kind of human thinking. So one conclusion we came to is that computer science is very effective if it's combined with human experience, so that we refine gigabits of data into megabits of data. And we have to ensure that the data we are producing is easily accessible, easily actionable, and does not require specific training. So one of the takeaway we came to after now almost 10 years of experience with drones and data is that data is worthless if it's not actionable, usable, user-friendly, and if it's not smart data. So I'm going to give you a few examples where technology was very helpful into doing things differently and doing things in a cheaper way. And I've seen that a lot of the people who spoke before me, they introduced very heavy machinery. We are all about small machinery, because in France maybe we don't have the same kind of I would say ambition or budgets to develop this big machinery. So yeah, this is the presentation is about software, but I'm going to get back to that. So one example I want to give you is like undercarriage inspection. In France, we have developed a small robot that can help with undercarriage inspection so that the trains do not have to be moved on a pit truck. With this technology, it's 10 times cheaper to inspect the undercarriage of a train. On catenary inspection, we are going 10 times faster with no traffic disruption when we are using drones to inspect the catenary or the electric substations. And it's very important because then we are not disrupting the traffic and the performance of the operation is maintained. For bridge and rock face inspection, drone can help prioritize the inspection, the detailed inspection. So we are not doing a detailed inspection with the drone, but we are helping the people to choose which bridge or which rock face they have to inspect in priority in order to avoid wasting time on infrastructure that is actually in a good shape. We have also trained more than 100 people to use drones, and we have around 50 drones in flights almost every day in France. I don't know if this number is big or small compared to the size of the Russian network, for example, but in France it's pretty big, and it's pretty tough to convince people that this kind of technology can be useful. And the impact of that is that these trained people with drones, often they are construction controllers. So it means that thanks to their drone, they can take pictures, they can supervise construction sites, and instead of doing one construction site management meeting in a day, they can do up to 10 construction site meetings in a day. So we are going to reduce the necessity of being all together on site in order to do a construction site meeting, because the data one guy will collect will be shared with his colleagues, and there will not be a need to meet on site to discuss the project and how it's going forward. So to do all that, we have on one side the data, we have the tools that are allowing us to collect the data.
Let me remind you of the time limit. Unfortunately, we don't have more time.
I'm concluding because what I wanted to say is that we need a platform, we need a software to make this data available, and that is the key we have developed. It's Altimetry Suite, a software in which you can centralize the data you have captured, make it easily available. It's user-friendly. You don't need any specific training. And I think in France, we have this challenge of density. A lot of things are happening all over the territory. And I think in Russia, you have the challenge of distance, because the work site and the people may not be on the same, even on the same time zone. So I think technology can help you bridge distances thanks to softwares, thanks to algorithms, thanks to tools that you will action in a different part of the country without being there. So one takeaway I wanted to give you is that technology can help you bridge the distance by having homogeneous, qualitative, smart data available across the country. And what we have developed for SNCF Réseau is a tool called Altimetry Suite. And I'm, of course, available if you want to discuss that later. You can find me on social networks. And I'm always happy to share some information with people from the larger railway family. Thank you very much.
Спасибо большое. Я думаю, что если бы Антоний Викторович...
Well, thank you very much. If you were taking part in our voting, you probably would give your vote for the optimization of relations with contractors, and maybe optimizing the number of personnel. But I think that, of course, this is a very relevant task, not only for France, but for us as well. Now, talking about the human factor, I have to ask some other people to speak about a subject which is not really maybe totally in line with the topic of our today's panel, but something that is important for the Russian railways and for the local and federal authorities. We know that the number of accidents at railway crossings is growing in most of the sections of the railways, and of course we need to have some technical or administrative solutions to really reduce the number of such unhappy accidents. And we have Vyacheslav Nevezhin, Deputy Minister for the Ministry of Transport and Roads of Novosibirsk region with us, and I would like to ask him to provide us with an answer. What can we do about that? Well, good afternoon, and indeed, thank you for really for raising this issue. Maybe we can have the slides. Yes, 2 years ago we started our project, and the railway crossing is now equipped with telemechanics, and it was connected to the barriers and warning lights. And our regional center started to receive data about the opening or closing of that crossing. Then we also identified several zones before and after the crossing, and there we can see how buses or any other vehicles are crossing such crossings. Now, on a software level, we more or less can see whether there is any problems with the warning signals on the crossing. So the program started to automatically register the violations that were made by the motorists in crossing the crossing. So in 11 such crossings in Novosibirsk, we are testing this system, and we have about 200 vehicles crossing the railways every day, and we registered about 600 violations of vehicles crossing the railways illegally. Currently, this is more like a preventive measure, but we want to really develop our system, and we had to really penalize those violating motorists, and in line with the Code of Administrative Offences, and perhaps we need to take a closer look at as to how to really impose fines on those vehicles that were not observing the warning lights on the crossings. We think that the safest way of crossing the railways is to avoid any really crossing between trains and vehicles, and we are trying also to match the timetable for the trains and the buses, so that the buses and trains would be running at different times across the tracks. We also want to really be in line with the instruction number 237 of the Ministry of Transportation of the Russian Federation, and using our system, we can have signals received in our regional control center about any failures of the equipment. We do see the opening length of time and the closing time for the crossings, and those crossings that are closed for more than 15 minutes, where you have some, heavy traffic, for example, and for example, at crossings of some service lines for enterprises, and if you are saying that, well, I mean, if that crossing is closed for 15 minutes just to pass the service trains of the enterprise, the motorists would really be more inclined to make some illegal crossings and bypass the signals. By the way, I have a question. Would it not be kind of like easier to install the usual CCTV so that it would more or less be linked to the database of the the police. And well, you know, such a CCTV, it's like 3 million rubles, but the devices that we are installing right now, those signals, they are only 9,000 rubles. So for those remote crossings with very small traffic, it would be kind of like unreasonable to install expensive CCTVs. However, we still can receive some telemetry and signals from the crossing vehicles. Well, thank you very much, colleagues. Unfortunately, the time that we were allotted by the organizers of our today's conference is over. I know that there are many questions that still remain, and we would love to do that, but we will have another opportunity for that. We are here during the whole day at the Expo, and all our newsmakers are also at the Expo, so you can talk face-to-face with them and use this unique opportunity that the Promotion.Expo is offering to you. So I would like to thank all of you for your very interesting contributions and presentations, and I hope that in some time we're going to see each other in some other events held by the GUDOK newspaper, and the next actually event is going to be the promotion forum in Sochi. So please remember to wear your PPEs and have a good day. Goodbye.